Over the years, Kenya is now being recognized as the ideal place to deploy climate technology such as direct air capture, and this is mainly due to co-factors such as renewable energy, because to run this technology you need clean form power, and Kenya's grid has a 93% renewable energy grid. It's not easy to find such places across the world, and notably out of the 93%, more than a third of it comes from the...
Today I brought on Specioser Mutheu, the manager of communications for Octavia Carbon. Octavia Carbon has direct air capture technology that removes CO2 from the atmosphere, and they leverage Kenya's renewable energy and use rocks as CO2 storage. Today, Specioser and I discuss why Kenya is ideal for DAC, how Octavia Carbon is making an impact, and what the future of carbon capture is in Africa. This is Earth ABC, featuring Specioser Mutheu. Thanks, Specioser, for hopping on. Really appreciate you joining me today.
Thank you, Sean. Happy to be here and to share my insights on Octavia Carbon.
So born and raised in Kenya, you've seen a bunch of innovative companies coming in and out, some staying. What really stood out to you for Octavia Carbon?
I think the whole idea of trying to use technology to address the climate issue, which of course we have seen growing up in Africa and in Kenya, where we are seeing flash floods and all that, was intriguing. And actually, I thought it was more of fictional. So when I first saw sort of the open position and tried to research about the company, I was like, oh, wow, they can do this with technology nowadays. So I was kind of interested in seeing how that pans out. So it was out of curiosity. Of course, Kenya and East Africa is majorly known as the Silicon Savannah. We have seen a lot of tech companies come up, and including in the financial sector. But something in the climate area as big as direct air capture company was really intriguing for me.
All right. So you're super interested in climate stuff, and being in Kenya, I want to scope out a bit. What makes Kenya specifically an ideal place for doing carbon capture work and carbon management work?
Kenya historically, of course, has been known as one of the biggest when it comes to projects for carbon removal on the nature-based side. But interestingly, over the years, Kenya is now being recognized as the ideal place to deploy climate technology such as direct air capture. And this is mainly due to co-factors such as renewable energy, because to run this technology, you need clean form power. And Kenya's grid has a 93% renewable energy grid. It's not easy to find such places across the world, and notably out of the 93%, more than a third of it comes from the geothermal sector, which is still growing and has the potential to generate more power for such technologies. Away from this, of course, we do have the ideal geology to store the carbon that is captured from these technologies. And this is mainly because of the geological formation across the Great Rift Valley. So in the Great Rift Valley, we have these basalt formations that can transform the carbon dioxide into carbonate minerals, which are essentially rocks. And of course, talent plays a key role in driving down the cost of different technologies and different sectors. In Kenya, we have a low-cost manufacturing base, and also the talent that can sort of accelerate the learning curve for these technologies and get them to where they need to be to address the climate issue.
So you mentioned these minerals and these rocks. Could you clarify for me what kind of action that they play in the ecosystem here in Kenya?
So in Kenya, we are, of course, a direct air capture company, the first in the global south, actually. So what we do is we are designing, building, and deploying machines that can filter the carbon dioxide from the atmosphere. Now, this we have coupled with storage for our pilot project, which will now leverage this geology to store the carbon that is captured from the machines. So essentially, how the rocks they are permeable and porous in nature, which allows the CO2, once injected in them, to kind of cut across the different sort of sections of the rock, and through this, it's now mineralized to carbonate minerals, which is essentially a thermodynamic nature of stored carbon.
I see. So your technology stores carbon dioxide into these rocks.
So our technology captures the carbon dioxide, but for the storage bit, we have partnered with a storage company that will handle that. And essentially what they'll do is inject the carbon dioxide into these porous rocks.
I see. So you mentioned air capture, and I've seen the acronym DAC. I imagine that they're related.
Direct air capture is essentially DAC, and it's just an acronym for the direct air capture process.
Gotcha. DAC technology, that's your bread and butter. I want to rewind a little bit. So the founding story of Octavia, what's the main problem that you guys are solving, and how did the company come about?
Yeah, so the founding story of Octavia Carbon, of course, it was conceived in two different worlds. In one world, Martin Freymüller, who is our co-founder and CEO, was working as a strategy consultant at Dalberg Advisors, where they were confronted with the question, how do you create 30 million jobs for the growing youth population in Africa by 2030? It is then he identified that carbon removal was a growing sector, and specifically dark direct air capture could be a catalyst for green growth in Africa while still addressing the climate crisis. On the other world, Duncan Karaoke, our co-founder and CPO, grew up in the lush green region of Mount Kenya, where he witnessed across time how climate change had impacted the agricultural lifestyle of the communities there. And during his engineering studies, he was quite determined to use his skills to address the climate issue. That's when he came across direct air capture technology. And in fast forward to 2022, that's when they met with Martin Freymüller through an online community called the Open Air Collective. And officially, they began operations for Octavia Carbon in June 2022.
That's pretty cool. How they were kind of were in parallel, seeing the potential of DAC technology, and then the first co-founder, how he was really trying to create jobs in Africa. I think both are wonderful things. Within 2 years, you guys made pretty much strong headway. So good to see that on that front. And I really love how simply you explained the DAC technology and how you have that partner for you to capture that carbon dioxide from the air, and then your partner helps inject that into porous rocks. How did you guys exactly determine that partnership in the first place?
It's an interesting because I believe when it was first founded, the business model was to develop direct air capture to help farmers, which was tied to the second founding stories for Duncan, where he was trying to solve also the agricultural issue within the Mount Kenya region. But we also noticed that there was a growing need for direct air capture in the carbon removal sector, which would require permanent storage of the CO2. So separately now, our storage partner had begun exploring the feasibility of carbon storage within the Rift region, and it is then our pilot project named Project Hummingbird, which is a direct air capture and storage facility, was born. So it was sort of best of both worlds aligning, whereby we have a storage partner who is exploring the storage side, and then we are now venturing into the carbon removal sector, where there's a growing need for durable carbon removal.
Mm-hmm. So it sounds like it was kind of like a natural partnership that came about.
Yeah.
And so DAC technology like that has been on the rise, meaning it's been around for a while, and your co-founders noticed like the potential for it. But how does Octavia Carbon's DAC technology compare to other carbon removal systems and other solutions like that?
So direct air capture, there are different forms, and it's deeply rooted on sort of what chemical filter you use to collect the CO2 from the atmosphere. So in our case, we use a solid sorbent, which is also developed in-house. And in one of the barriers you will discover across historically dark what has been hindering its growth is the energy intensive nature. So to address that, at Octavia Carbon, we are finding ways to optimize for energy use. And essentially, given the growing geothermal sector within the Kenyan and East African region, we are trying to integrate our direct air capture with this key resource that is vastly untapped and lacks the adequate demand to drive its growth. So it's kind of a domino effect. By trying to solve the energy requirements of direct air capture, we are also creating sort of an industrial demand for the geothermal capacity in Kenya, because currently it's stifled because we don't have that industrial demand for the energy that is being produced, and much of it ends up being wasted. So we need those energy hungry industries in Kenya that can leverage this capacity. And to go a step ahead, instead of just leveraging the electricity from the geothermal sources, we have designed our technology to utilize the waste heat. And this waste heat will cater for more than 80% of our energy needs for direct air capture, while only 20% will come from the electricity.
Wow, that's actually a pretty big split. Yeah, and in terms of where you guys are at right now, is this a solution just available in Kenya, or is it more broadly available in Eastern Africa? Where can we find the Octavia Carbon solution?
So currently we have two locations. One is in Nairobi, within Nairobi, whereby we have a manufacturing and a research and development facility. Here is where we are making low-cost dark reality. And of course, where we are deploying our technology is still within the Kenyan Rift Valley region. This is where we have Project Hummingbird, our pilot direct air capture and storage facility. In the long run, we are thinking of expansion across the East Africa with regions that offer the same resources as Kenya, because arguably you'll hear us sort of like a broken record saying Kenya is the world's best place to develop and deploy dark at a low cost, and sort of our track record speaks for itself, and it's evident. It's been evident. So over the years, we might consider regions like Ethiopia that have the same resources, but for now, Kenya is the world's best place for dark.
And so when it comes to, I guess, Octavia Carbon differentiating itself from other climate tech and clean tech companies in Kenya, and you're talking with people who might be adopting these types of solutions, how do you guys approach those conversations and really make yourself stand out?
So, of course, direct air capture is a novel industry, and especially in Kenya, being the first to do this, there is a lot of knowledge base that needs to be created, and even to incentivize the growth of policy within the industry that will make it possible for us to scale at the rate which we want to scale to. So how we are approaching this, first we foresee dark is where solar was about 25 years ago, and for us to get to where it is now in terms of cost, we need sort of to bring everyone on board. This is policymakers, our local communities where we intend to deploy this technology, so that in the long run, they can have a piece of the pie of the cake we are currently sort of baking. And so, yeah, it's sort of all hands on deck from all stakeholders, and central to this is our communities, which you believe they have they sort of have that ability to make or break Octavia, in the sense of they are the ones that are making it possible for us to be where we are now. And as a reflection to this, we recently released our community engagement strategy, which informs ways in which we are approaching sort of communities and co-developing our projects, making them that they understand every step of the way and why we need to develop this in Kenya, and just 5 kilometers from where they stay. And in the long run, what benefits can this technology have?
You touched really early in your response how it's affecting these law and policymakers and then other parts of government. What does that front look like in terms of Octavia Carbon's collaborations, people that they're working with, but also challenges that you guys might be facing in terms of legislative policy support, things like that?
So currently we are privileged to be in a region where carbon removal is not new, in the sense that we have had a lot of nature-based sort of projects happening, and there's a large incentive from the government to sort of drive those national determined contribution and even to take part in sort of initiatives such as Article 6. So what the bridge is now sort of introducing the engineered carbon removal, which is entirely new because people in Kenya are accustomed to planting trees. I think we even have an initiative where we aim to plant a couple of million trees by a certain time. So for that, for us, it's been more of creating that knowledge base with the different stakeholders within the policy area. This includes the relevant ministry that would inform the policy for direct air capture. There's been a lot of support and a lot of green light from the Kenyan government, and sort of we can say that's a blessing. Challenges, of course, policy work takes time, and of course it's not gonna happen overnight for us to have major incentives or major subsidies compared to other regions that have had these subsidies, but just having the government endorse what we are doing is such key for us.
What are some economic and social benefits of the DAC technology that are very unsuspecting and people normally wouldn't know unless they're in the field?
Yeah, so DAC in Kenya, we usually say can be that sort of engine that drives green growth within the region. And this is mainly because by virtue of us manufacturing our technology here, we are able to create jobs within the manufacturing area. Currently, we are a team of about 60, more than 40 of which are engineers. And we see this growth sort of the team size being exponential in the sense of we can get to thousands by the time we're getting maybe to a gigaton scale. Away from local job creation, the revenue generated from the carbon credit sales, whereby these carbon credits will come from the projects that we deploy in Kenya, have the ability to support local initiatives, and this forms the basis of sort of the community engagement strategy, where a fraction of the revenue from the carbon credit sales can support local initiatives. We usually say $1 in Kenya goes a long way than in another place. So this gives us an incentive to support educational programs, to even support local initiatives such as beekeeping and create sort of a resilient livelihood for our communities. Away from that, DAC can also be support other green industries such as green steel. It can also support the sustainable aviation fields, which is also a growing sector. So by virtue of us creating that direct air capture ecosystem in Kenya, we are incentivizing growth of other sectors in the region as well.
So basically empowering a lot of economic systems, a lot of pretty much initiatives in government stuff through those carbon credits even. So huge benefit, and not to mention just the jobs that it provides. So that's all wonderful. And in terms of the flash flooding that you mentioned early on that you noticed, well, again, being born and raised in Kenya, how does carbon capture help address some climate issues like flash flooding?
So carbon capture essentially is the removal of carbon dioxide from the atmosphere, and essentially we are living in an overshoot scenario whereby the accumulated carbon dioxide in our atmosphere is causing these advanced effects of climate change. And even climate science advises that we need to be removing 5 to 10 billion tons of CO2 from the atmosphere if we need to mitigate such impacts. So currently the state of affairs only sees about 2 billion to 3 billion of carbon removal being done. And this shows how we need to grow this sector if really we are to keep these sort of effects at bay. So by virtue of us helping remove the carbon dioxide from the atmosphere and also achieve net zero targets will help kind of sort of keep these effects such as flash flooding and all that, but more in the long run, not now. We are not saying that we'll wake up tomorrow and there'll be no flash flooding. It's more of a long-term solution and helping us sort of to mitigate these changes.
So it's not really by a snap of fingers per se, but rather it's a snowball effect on the climate, specifically naturally occurring events. So yeah, I can see the way that you're seeing in terms of long-term climate effects as well. And since we're on the topic of long-term, what's next for Octavia Carbon? I know you were talking about expansion, but also what's in it for Octavia Carbon in terms of innovation and optimizing the technology and beyond.
Currently, technology-wise, we have built a module that can capture about 20 tons of CO2 in a year. Our goal is to scale this capacity in terms of what a unit can capture. And this model specifically is named Lenana, after the lowest peak of Mount Kenya. We kind of draw the inspiration for the names from Mount Kenya. So Mount Kenya has 3 peaks. We have a Nelion and a Batian, and our aim is to create a Batian, which will be a sort of machine capable of capturing 1,000 tons of CO2 per year within sort of the size of a 6-foot container. So yeah, technology-wise, that's a place we hope to be. Away from that, despite deploying our technology here in Kenya, whereby we build sort of that engineered carbon removal sector, we also aim to expand to other regions and also become sort of a dark original equipment manufacturer, where we are seeing not every other company wants to develop direct air capture from scratch. Some want to procure from project developers who have gone through the entire process of developing this technology. So in the long run, we want to be sort of a supplier for these machines. And we are also considering venturing into the sustainable aviation field. And like we said, dark can be an engine for green growth in Kenya. Interestingly, we have green hydrogen in Kenya, a power plant coming up that could be sort of, we could lie us to create hydrocarbons such as sustainable aviation fuels and creating a new revenue stream for us.
And so I'm a very visual person. What does Octavia Carbon's DAC machines look like?
So the machines, our current form factor is sort of cylindrical, and they have a sort of a footprint of 2 meters by 2 meters, and they are the ones that can capture about 20 tons of CO2 in a year. Basically, how they look like is we have a fan that helps blow the air through the chemical filter, and then once the chemical filter is saturated, the unit is fully closed and vacuum conditions are sort of applied. And then we heat the filter that releases the CO2 still within the cylindrical machine. And then this carbon dioxide is now channeled to a tank for conditioning for storage purposes.
And once you have that in store, you hand that off to your partner, who then injects it into these porous rocks. Gotcha. Cool. Well, the more and more that we talked, the more I was able to kind of see the benefits that really permeates throughout the Kenyan economy, the Kenyan green space, like you mentioned, the green aviation. I think that's amazing, and it really helps fight climate change and overall the climate crisis that we're seeing around the world. Whether it's broadly speaking or specifically for Octavia Carbon, what are you most excited for, Specioser?
Usually excited by our agility in terms of tackling challenges. It hasn't been an easy road. Within the 2.5 years of developing this technology, I think every time we build a new design, we usually think this is it, but then we encounter a problem and then we realize, oh no, we need to go back to the drawing board. So that agility and just having a sort of that ecosystem that's determined to build this solution is usually so interesting. And not only you'll notice we are sort of a young team, and just having these young people who are trying to solve this challenge and every day waking up thinking, oh, I'm going to build a solution that could change the world that we live in is usually so encouraging.
That's amazing. I mean, any startup that's agile, we're all for that. Love that you guys are moving fast. Love that you guys are iterating on new knowledge, new challenges. So very much wishing you all the best of luck. And You as well, Specioser. Thanks for tuning in. If you enjoyed this interview, follow along on Earth ABC's LinkedIn to stay connected and never miss what's going on in climate tech. If you'd like to reach out or you're interested in coming on as a guest, feel free to connect with me, Sean Pack, on LinkedIn. We're always looking for inspiring ventures and founders in the climate space to feature on the show. Hope you enjoyed. Until next time.